This is a computer chip multiplied 500 times. What you're looking at the top of the computing city, with distinct neighborhoods for different functions. They are linked by up to 100 kilometers of ultra-thin copper lines running across 10 or more stack levels. At the very bottom, billions of electronic devices generate the digital traffic that passes across the chip. The most common of these devices is called a transistor. It's a switch that allows current to flow if received voltage. Transistors can be as small as 20 nanometers, and more than 50 billion of them can fit on a single chip. Globally, we produce more than a trillion computing chips every year. That's about 20 trillion transistors built every second. It's done in a fewer than 500 fabrication plants, known as fabs. How do we build so many tiny, intricately connected devices so incredibly fast? The answer involves a technology called photolithography, which helps us build all the devices on the chip simultaneously. It's like constructing all the buildings in the city at the same time. And with an on-time construction crew to help, we build using lights as a measuring and sculpting tools. The process starts with a vapor of silicon, which dissolves in the solvent and acid to strip it clean before entering the furnace. Here, oxygen gas reacts with vapor to form a layer of silicon dioxide. Then a liquid called photoresist is spun on. And baked to harden. Next, ultraviolet light circuitry illuminate the vapor by passing through or reflecting off the specialized mask. In the lit areas, a reaction weakens the photoresist chemical bonds. The vapor is down to another chemical to wash away that weakened photoresist, leaving an image of the mask. And the etching machine reactive gases remove the exposed oxide, creating windows that draw the mask patterns down to the vapor's surface. And the implanter accelerate boron and phosphorus ions that swarm them into the patterns of openings. These atoms form electropositive or electronegative regions that change the silicon conductivity, creating the foundation of the transistor switch. The edge oxide windows, however, create hidden valley features before the next level of copper lines are added. This one uneven lines must be polished flat to near atomic precision using a sophisticated grinding process called chemical mechanical polishing, or CMP. CMP uses controls slowly of submicron ceramic particles to gently scrape and flatten the bumpy features. These five tools and many others are used in hundreds of times on vapor to create a link transistor into the computing logic base and make connected neighborhoods for memory storage and computation. Fabs run around the clock and takes about 3 months to transform a single vapor from a pure silicon into hundreds of chips. With this continuous operation, fabs consume huge amounts of electricity, water, solvent, acid, and bases, processed gases, and precious metals. Vapors are processed in ultra-high purity tools chambers, maintained by pumps running constantly to sustain a vacuum that resembles deep space. High-temperature furnaces never turn off. Fab air hunters constantly expel filtered air to crowd dust and tiny particles away from vapors. This takes a lot of electricity. The chemical and purified water used in cleaning create nearly 5 gallons of waste per vapor run, which needs to be filtered and pH treated. Meanwhile, CMP solids continually flush with water to keep their fine particles from Meanwhile, CMP solids continually flush with water to keep their fine particles from forming chunks that would tear apart the fragile copper lines. This adds 5 times more liquid waste. Fab pass through vast amount of nitrogen and helium gas to run their tools, and other gases used and generated in these tools are greenhouse contributors. To minimize their emissions, machine called scrubblers decompose and dissolve some gases byproduct into the treatable wastewater that uses more electricity and more water. As computing complexity grows, more copper and precious metals are needed to link up chips, and new problems arise. Today, people-based photo bridges are essential to make even smaller features, but people space in the environment is ending up in our bodies. It may be harmful. Computer chips are modern marbles that have transformed the world, and the factory that built them are themselves engineering wonders. But as the demand for chips accelerates, their publication is hitting hard sustainability limits. Already, some places are beginning to ration the water to farmers in favor of running fabs. For the sake of the future of computing and environment, tomorrow's leaner, cleaner, and greener fabs will need to run even smarter. Run even smarter than the very chips they need to build. We do not even smarter